So this is our lesson 7.1 on zero and negative exponents. A little review. Exponent tells us how many times a number, the base, is used as a factor. The base is the bottom number. Exponent is the top number. That tells us how many times we have to use it, how many times this base gets multiplied out. 3 to the fourth means we have 3 as a factor 4 different times. A quick way of multiplying this together rather than taking 3 times 3 times another 3 times another 3 is by grouping. This 3 times 3 is 9. This 3 times 3 is 9. So we're really taking 9 times 9, which is a little easier. 9 times 9 is 81. These next two examples show the difference and importance of negatives in parentheses. In this first one, the exponent, the 4, is actually just controlling the 2. 2 is the base, not negative 2, just 2, which means we have 2 multiplied together 4 times. 2 multiplied together 4 times here. And a negative out front. So we've got our 2's multiplied together, a negative out front there. So we can think of this as multiplying these 2 times 2, which is 8. 4 times 2 is 8 times 2 is 16, with a negative slapped out front. That's different than this next problem, where now the base is this whole business, negative 2 and everything. The parenthesis is holding it all together. So here I need negative 2 multiplied together 4 times. Negative 2 multiplied together 4 different times. So now I take the negative with each time in the parentheses. Negative 2 times negative 2 is positive 4. I might do the grouping thing again. Negative 2 times negative 2 is positive 4. And 4 times 4 is 16. So be careful with the negatives. If you have a parenthesis, it goes with the whole way for the whole ride. And if it doesn't, then it just sticks out front and gets slapped on at the end. If I'm going too fast, pause it when you need to. Copy down your problems in your notes. Our first rule of exponents is that when you raise it to a 0, the answer is a 1. When you raise it to a 0, the answer is a 1. Done. Anything to the 0 power is 1. So 5 to the 0 is 1. When we look at the next one, negative 6 to the 0, again, we have to kind of realize that the 0 power, the base on that is just the 6. 6 is raised to the 0 power, just the 6. So this is 1. But we still have the negative out front. So my final answer on this one is actually negative 1. So we have a negative, and then we have the 1. C to the 0, anything to the 0 is a 1. And the last two problems, raise it to a 0. This whole thing is being raised to the 0. That means this whole thing is equal to 1. Raise it to a 0. The answer is a 1. So b to the 0. This is really 1. Just the b to the 0. Everything else stays. So I've got 6a squared times 1 times c to the 4th. I think we know that if that's the case, we can just ignore that 1. When we multiply by 1, it doesn't change anything. That would be my final answer. Rule number 2. Negative exponents in the way? Flip it over the bar. Yeah, that's the way. If you have a negative exponent in your problem, it can't stay. We have rules in math. We don't like to see anything with a negative exponent. So if it's there, we have to get rid of it. And the way we get rid of it is flip it over the fraction bar. and I'll explain here in a moment. So this first problem, 4 to the negative third power. And you might say there is no fraction bar here, but we think of 4 as like 4 over 1. So this has to flip over the fraction bar. To get rid of that exponent, I have to move 4 to the third to the bottom. And when I move it, I lose the sign. So the negative turns to a positive there. I need a placeholder on the top. Something needs to be up there, so I put a 1. Now, I can simplify this. I could leave it like it is, or I could simplify because I know 4 to the third really is 4 times 4 times 4. And we may or may not know that that's 1 over 64 would be your final answer for that one. Next problem, negative exponent. So this whole thing, negative 5, is raised to this negative exponent, which means the whole thing needs to move down to the bottom. Needs to flip over the bar. So on the bottom, I'll write this exact, problem. So this now goes on the bottom of the fraction. Again, the negative exponent here changed to a positive here. I need a placeholder on the top, so I put a 1. In this problem, negative 5 squared on the bottom. Negative 5 is in parentheses, so negative 5 is the base. So I take negative 5 times another negative 5. I get positive 25. So the answer is 1 over 25. Feel free to pause when you need to. Next problem, negative 2 again. Well, this time the 3 is what gets raised to the negative power. The 3 alone is what needs to move down to the bottom of the fraction. So on the bottom, I put 3 squared. On the top, I need a placeholder, a 1. And actually, this negative here needs to remain, needs to be placed somewhere. I'm actually going to put it right on the top with that. So I'm basically looking at this as the negative stays. This drops down to the bottom. Clean it up. On the bottom, 3 squared is 9. So my final answer would be negative 1/9. And the final problem, negative exponent. Flip it over the bar. In this problem, m has a negative exponent, just m. So m is the only thing that needs to get flipped over the bar. M is the only thing that needs to move. So the 8 can remain, and m to the 5th would move down to the bottom. I don't know if you can see that. 8 remains, m to the 5th on the bottom. So lastly, if you have a negative power that's on the bottom already, so it's already on the bottom, it has to move, flip it over the bar. If it's on the bottom, it has to move to the top. So this negative exponent, flip it over the bar, so it goes on the top of the fraction bar. So now I have 1 m to the 4th. We could write that as just m to the 4th as well. Negative exponent, flip it over the bar, has to move. Negative exponents can't stay, they have to move. So this negative exponent, just the thing with the negative exponent, moves up. So it gets to join the 3 on the top. Oops, 3 to the 2nd, not 3 squared. Or cubed. Okay, 3 to the 2nd, yep. All over, x cubed has to stay on the bottom. It does not get to move. It doesn't have a negative exponent, it has to stay where it's at. This is our final answer here. Okay. This guy, negative exponent, b to the negative 4th, that has a negative exponent, that has to move. Now, this is a tricky problem here. We have a negative 5 on the top, right there. But that's not a negative exponent, that's just a negative number. And you've been dealing with negative numbers for the past couple years now. and you haven't done anything special. You've never flipped them over the bar or anything. So don't mix these rules up. Negative exponents make things move. Negative numbers are just negative numbers. So negative 5 stays on the top. Switch colors here. And we get negative 5 on the top, and b to the 4th joins it. Last problem. Negative exponent, I have, let me look at it for a little bit. 9x to the negative 3rd y. So this negative exponent has to move down to the bottom. On the bottom I have 3z to the negative 2nd. Well, this negative exponent, that has to move. Flip it over the bar, it moves to the top. Now they're not switching. This moves because it has a negative. This moves because it has a negative. Both of them have to move. So then my answer, I have a 9yz squared on the top, and on the bottom 3, and then the x cubed joins it. And we can clean this up a little bit. 9 over 3. That can reduce. 9 divided by 3, it's just 3. So on the top I have 3yz squared all over x cubed. Last problem is evaluating. This will go very quickly. Evaluate 8a to the negative 2nd, b to the 0, 4, a is negative 2, b is 6. So here's our directions. If you simplify first and then plug the numbers in, your life is going to be easier. So simplifying first, raise it to a 0, the answer is a 1. So it kind of cancels out. It's 1. It doesn't change my problem. And then negative exponent has to move. So I guess at this point I'm at here. B to the 0 is 1, so if I times by 1, it doesn't change anything. And then the last step, negative exponent has to move. Negative exponent, flip it over the bar. So now I've got 8 over a squared. Okay, that's simplified. Now plug your numbers in. 8 over a negative 2 squared. Negative 2 squared means negative 2 times negative 2, which is a positive 4. 8 over 4 reduces. The answer is 2.